Hello everyone and welcome to GridGain Systems webinar, Troubleshooting Apache Ignite. I'm Nicole Van Gelua and will be today's moderator. Before starting, I will need to conduct a little housekeeping. Can you raise your hand with hand icon on the left of your screen if you can hear me? I don't see any hand raised, but I don't see any question marks either, so I'll assume that you can all hear me. So we are good to go. On behalf of today's webinar presenter, thank you for joining us. I'd like to introduce our speaker for today, Stanislav Lukyanov, Customer Success Team Expert, and Stan has a focus on Ignite. If at any point during the webinar you have a question, please type it in the Q&A panel. Questions will be addressed at the end of the webinar. Please also note that your phones will be muted throughout the presentation. You've joined us today to hear about troubleshooting Apache Ignite. At the end of the webinar, we'll close out by taking your questions. With that, I'd like to now turn things over to our expert, Stan Lukyanov.
Hello, everyone. Thanks for joining today. My name is Stan. I work in customer solutions team at GridGain, and during my work, I help our customers to build and maintain Apache Ignite and GridGain clusters, and I and my team, we collected a lot of experience there. And today I want to share some experience with you regarding troubleshooting Apache Ignite and GridGain clusters. So first, let's start by talking a bit about the product itself. So most of you probably already know it, at least Apache Ignite. So Apache Ignite is a distributed database and data processing system. It has such features as memory data grid, persistent database, and many more. And GridGain is a product that is built around and on top of Apache Ignite, and it provides additional features such as monitoring, security, disaster recovery that are usually required by enterprise level customers. So at GridGain, we have always offered support for the GridGain products. And just recently, we have introduced a new service that is called Basic Support Offering for Apache Ignite. It includes 2 hours of initial consultation to get you up to speed, to review your architecture, probably review your configurations and code, and make sure that your cluster is good to go. And most importantly, unlimited web-based support, where we can help you to identify bugs or troubleshoot issues that you come across, find solutions and workarounds for them. What this offering does not include is patch releases, because the customers are expected to use regular Apache Ignite versions. But it will surely help you in troubleshooting. So what are we going to talk about today? We'll start by reviewing some monitoring capabilities, because monitoring is the key to troubleshooting. We'll review different tools that can help you to monitor your clusters. and find the issues there. Then we will review several common issues that are relatively easy to find if you know about them, and so that you can fix them if you ever encounter them. And we will finish by going through a small checklist of things to keep in mind when you building and having in production your Ignite and GridGain clusters. So first, monitoring. So why is it important? And I guess most of you would know that yourself, that if you only set up monitoring after something happens, which is unfortunately a case in many systems, then when you encounter an issue, you will not be able to do anything about it. You will not have any information, and you will just don't know what has happened. So to avoid this, make sure to set up monitoring not after, but before you go to production, before you encounter some actual issues. And let's just take a look at what monitoring capabilities Ignite provides. So first, monitoring capability is, of course, simple logging. So what can you do with logs? First, this is the easiest way to check the state of the nodes and the cluster. Of course, it is not the most convenient way because you usually need to log into a server and open a text file, go through it manually like with your eyes. But still, sometimes this is just the thing that you need when you don't have any other tooling around. Logs help you to identify issues with your cluster. All of critical errors that happen in Ignite cluster will be shown in the logs, and even some configuration issues that might not be critical, but that Ignite can detect and report will also be in the logs, often with some suggestions for the solution. Some users add automatic parsing to report issues on the fly based on the logs. There is no tool like that available or out of the box in Ignite, but you can use some third-party tools or write a custom one for that. And if you use or going to use GridGain support services, for example, the new Apache Ignite basic support, then usually the first question that you will get from a support engineer would be to get all the logs from all of the nodes in your cluster, because they are always crucial for troubleshooting. So how do you configure GridGain logs? And this is actually an easy thing to do. It is all explained in our documentation on Apache Ignite README IO. The only thing I would mention here is that we have a number of integrations with different logging frameworks, but I personally suggest to use Log4j2 because this is one of the most advanced and one of the most widely used frameworks out there. And integration with it is very easy. Also, I would recommend to start Ignite in verbose modes, either by using a command line switch -v or by using Ignite quiet system property. So what is verbose mode? By default, Ignite will start in a quiet mode, which means that only the most critical, most important things will be in its standard output, in its console output. And usually you would want to have just all the information there. And to have all the information, you start it in this verbose mode. So, for example, this is the log in the quiet mode that Ignite produces on the first start, and this is like not that long. But if I was to show you the full verbose log just from the Ignite node start, it would not even fit on the slide. But this is actually a good thing because it has a lot of additional information that is crucial for troubleshooting. You need not only Ignite logs, but also garbage collection logs. So Ignite is a Java-based platform, and as anything that is Java-based, it relies on healthy garbage collection a lot. So as with other Java tools and Java applications, you need to configure GC, and to do that, you just use these command line flags that are on the slide. And this is also documented on our README app. Then, how do you manage the logs after you configure them? First thing, you need to carefully choose the location for your log files. It should be a local disk, not a network one, because network disk may not be available in case of some failures. You should not use /tmp because on most Linux systems it's tmpfs, and it will be cleaned up after every system restart, so you might lose your log files. And it is a good idea to store GridGain application and GC logs all together so that they are easy to manage, easy to archive, and easy to share. You will need to archive all log files, and it is better than just deleting them, so that you can look at what happened to your cluster in the past. And it is good to save the logs at least for the cluster's current uptime, meaning from the system start, because for troubleshooting some of the issues, you would need to have logs since the very start, since the start of the first server in the cluster. Sometimes you will want to change login configuration. For example, add some verbosity to your logs. This can be done easily with different log frameworks, and this can be easily done with log4j2. First, you can just edit the log4j config file. Just edit the XML file with the configuration, and the system will reload it after some short period, about a minute. Or alternatively, you can use JMX. Log4j exposes its own JMX bin that allows to change some configuration, and you can see on this slide a screenshot of JConsole tool showing that log4j configuration bin. So the next topic in this about the monitoring is JMX. So what can you do with JMX? JMX is a standard way of monitoring and managing Java applications, and Ignite is not any different. We saw already that JMX can be used, for example, for Log4j, and it can be used for Ignite as well. Ignite exposes some JMX beans that provide information about various components. So you can check the state of the cluster right now through JMX. You can collect the metrics and store them somewhere and monitor metrics changing over time. You can build some charts and build monitoring around that. And again, some users like to set up automatic warnings for some important metrics, for example, reaching a threshold. For example, you might want to have a warning that will tell you that you are running out of disk space. How do you use JMX beans? So again, this is the standard way to monitor Java applications. So there is a lot of different tools out there, from the very simplistic to very complex monitoring systems. A couple of the easiest ones that will help you to check the state of a running cluster are JConsole and Visual VM, which are bundled together with standard JDK. And on this slide, you can see JConsole showing some Ignite beans. So which JMX beans Ignite exposes and which ones do you want to check and monitor? On this slide, you can see a number of different beans with JMX queries that you might execute or might use in your JMX monitoring system. I will not go over them in detail. I will just note one thing. In the right column, you can see whether the beans are enabled or disabled by default. And for most cases, I would suggest enabling all of these important metrics. For example, data region metrics is some crucial memory information. Enabling this metrics has some very small performance penalty. That's why it is disabled by default. But from my experience, I can tell that it is worth having this some small performance loss for cluster maintainability. Finally, the most complete solution that Ignite and GridGain provide is the GridGain Web Console. So GridGain actually and Ignite as well, they come with a variety of monitoring and management tools. So the first and the simplest ones are command line tools, which are listed on the right of this slide. They are available in Ignite, and these are multiple command line scripts that help you manage the cluster. Visor CMD, Visor command line, is a tool that helps to monitor the current state, the topology of the cluster, and do some administrative tasks like stopping a node. Control SH is a tool that is built for some of the most important management tasks, such as topology change management and transaction management. And SQLine is a small tool that helps you to connect to the cluster and run some SQL statements. Visor GUI is the next tool, and this is now a sort of a legacy tool that is available in GridGain Enterprise and Ultimate editions. This is an all-in-one Java-based solution that runs on a user PC. This is a Java user interface application. It connects to your cluster and provides various ways to monitor and manage the cluster, from checking the topology to checking all of the processes that run in the cluster, to running SQL queries, and so on and so on. And the most modern solution is GridGain Web Console. Actually, the basic version of it is available in Ignite, and enhanced version is available in the GridGain templates. Like Visor GUI, it is an all-in-one solution, but unlike Visor GUI, it is web-based. It does not run on the user PC, and it provides the richest functionality as of the moment. So what can you do with Web Console? First, you can manage not one, but several GridGain clusters at once through a web interface, through your browser. You can monitor Ignite cluster state and metrics, and Web Console will also build some charts with metrics changing over time. You can access logs right through your browser, and you can download them to your local PC. And you can execute and monitor running SQL queries as well. Web Console can also help you to start to build your cluster by generating some configurations for you. How do you try it? How do you use it? First, there is a version available online at console.gridgain.com. You just log in, register on the site, and connect that Web Console to your cluster in your network, and just use that without any installation. And for production use, you would probably want an on-premises installation, which can be easily done using Docker or even bare metal, and it is all explained in the documentation. Let's just quickly take a look at some of the Web Console capabilities. First is the metrics dashboard, and this is the main Web Console screen, the cluster dashboard, and here you can see some of the metrics that Web Console shows. You can check configuration for any node, and you can also dump the configuration to a text file and download it. You can check out the logs without the need to log into the servers. Just check them online and also download them. And there is an SQL tools such as SQL queries notebook and runner, and running queries monitoring. So we have reviewed different monitoring capabilities available in Apache Ignite and GridGain. And next, let's take a look at some of the issues that are common in newly built and even running clusters running in production. I will break these issues into three categories. The first issues related to networking, building your cluster, holding it together. The second group is issue with the main functionality of the cluster, which is to store data and provide access to your data. And final group is performance of that access. So what kinds of network issues are there? So you might see that your nodes are not able to join your cluster or not able to find each other. You might see that sometimes nodes joining wrong clusters and clusters merging when you don't want them to. You might also see other issues with nodes joining and holding in together in the cluster and nodes being kicked out of it. So the first kind of issue, nodes not joining together. And how does it look? So suppose you have started two nodes on two servers, and uh, you expect them to connect, but the first message that you see, actually the last message in this first screen after the startup that you see is topology snapshot version 1, servers 1, and you see that on both nodes. So what does it mean? It means that both nodes haven't found any other nodes to connect to, and both has started a new cluster of version 1 for themselves, each cluster having only one server. So you have two clusters with one server instead of one cluster with two. Why is that so? So first, you need to check for any connection issues. And as usual with any network issues, you just check them by usual commands like ping. You check your firewall settings. You make sure that your firewall allows to connect to certain TCP ports that Ignite uses, and you can see the list on the slide. And if all of that is okay, then the issue is likely with your IP Finder configuration. IP Finder is a component in Ignite that is responsible for nodes, well, finding each other IPs. And this is the component that you need to configure to properly discover other nodes. In most cases, you would want to use the implementation that is called TCP Discovery VM IP Finder. It contains a list of all nodes with all of their ports, just hard-coded in the configuration. And whenever you know all of the nodes, all of the addresses beforehand, you probably want to use this implementation. If you use that, just make sure that you have listed all of the IPs correctly. If you don't know all of the hosts in advance, or you just have too many of them, or don't want to bother managing that hard-coded list, there is a lot of other IP Finder options based on Kubernetes, based on various cloud services, or on different technologies and solutions. They are all documented on README.io with guides on how to use them and how to configure them. So a different kind of issue, like an opposite one. You have just started a single server, say on your development laptop, and the first topology snapshot that you see is not version 1, it's version 2, and it shows two servers, or maybe it even shows more. But you know for sure that you have only started one. It means that you have connected to some unknown cluster. But how could it happen? Most likely the issue is again with IP Finder configuration. And most commonly, this is caused by using multicast IP finder. So the default IP finder that is used in Ignite, the one that is used in Ignite examples, is TCP Discovery Multicast IP Finder. It uses multicast groups to connect to other nodes, and it looks up all of the nodes that are running in the same network, basically all of the nodes that your new node can access. It will try to connect to any of them to join their cluster. It means that when you use multicast, all of the nodes in the same multicast group will always end up in the same cluster. So if you run with such configuration, say in your office, where you do some development on your laptop and your colleagues do that as well, you're likely to run into issues with you and your colleagues connecting to each other's laptops and forming a single cluster instead of multiple ones. So you can use multicast IP finder in some closed subnets. You can use it when you know for sure that there will be only one cluster reachable in the subnet, but in other cases you are better off using some other IP finder implementations. If you are not using multicast, it's still possible that IP finder configuration is incorrect. You might list wrong IPs, or you might configure other kinds of IP finders, such as Kubernetes IP finder, incorrectly. So if you run into an issue like that with nodes joining wrong clusters, just check your IP finder configuration and make sure it's correct. The next kind of issue is nodes connecting to the cluster, but just taking too much time to do that. Often it looks like a node tries to connect to a cluster, and when the first node starts, it takes a very long time, and all other nodes that try to connect to a cluster actually start up fast. Like first node might take minutes, and all other nodes take seconds. And you might not even see any other performance issues. So why is that? The usual cause for this, a common cause for this, is having too many addresses in the IP finder. So it's again all about IP finder configuration. So how discovery in Ignite clusters work, how IP finders work, is that IP finder provides a list of addresses, and then the starting Ignite node will iterate over each of them and try to connect to each of them sequentially. If connecting to a single address takes a long time in your network, and this may be the case in some networks due to network configuration, when the connections take too long to connection attempts take too long to fail, iterating through a long list of IPs might lead to long startup times. So you should either reduce the startup time, the number of addresses to reduce the startup time, or you might try to also change your timeouts of Ignite configuration. So there is a timeout that is called failure detection timeout, which is used for a lot of different operations in Ignite, and this is like the basic generic timeout for single operation. And this is also used for a connection attempt. So if you just make it shorter, then each connection attempt will be shorter, and the first node will start up faster. And the final issue in this group of issues with cluster networking is nodes being kicked out from the cluster uh, after working normally. How does it look? So uh, your cluster nodes, the other ones, will report in their logs a message node failed, showing IP address and ID of the failed node, and the failed node itself will say local node segmented. And that's basically it. You might not see any other errors suggesting that some critical issues have happened in the cluster or on that node. So why has the node failed? A likely cause is a garbage collection pause. So what local node segmented means is that the cluster has decided that the node is no longer in the cluster because it hasn't responded to for a long time. And after that, after the node started to respond, after the node has tried to connect to the cluster again, the clusters responded that, hey, we have already kicked you out. We thought you had failed. And because of that, the node says local node segmented. And usually it will happen due to garbage collection pauses. When you have stop the world pause in the node, in the JVM, which will cause it to not reply to any requests, any heartbeat messages, any pings from other nodes in the cluster. To confirm that hypothesis, you can check for a message possible to launch JVM pause in the logs. And if you see that, it means that Ignite has itself detected some issues with Stop the World collections, or at least that it hasn't have got any CPU time in some time period. And you can also use some tools. For example, GC Easy IO is a great web-based tool to analyze your GC logs and which can provide some suggestions on how to tune your GC. So how do you handle your GC issues? The first thing that you could do is just as a remedy, try to increase your Java heap size. And this is the usual solution for any Java application. Another thing is trying to use G1 garbage collector. And in Java 8, you need to enable it by using a command line flag. And sometimes it will help to reduce the garbage collection latencies and stop the word pauses, so as to avoid this issue. And if that doesn't work just like that, you might need to reduce heap pressure that your application creates on the garbage collector. First, you can try to use smaller SQL queries and query less data each time, which will usually help, as SQL is one of the most important users of Java heap in Ignite clusters. And we will talk more about tuning SQL a bit later. You can use vskip binary method if you use Java API to access Ignite caches. And vskip binary will help you to avoid deserialization. And finally, there is an option of on-heap cache that you could use. And it is important to use it with copy on read false property. which will mean that your data will stay on the heap and it will not be copied a lot. And this will greatly reduce allocation rates on the Java heap and reduce heap pressure, make the life of garbage collector easier. You can also increase failure detection timeout, because failure detection timeout that we saw previously is also responsible for specifying the amount of time a node can not respond the cluster's requests before cluster kicks it out. So if you say set a failure detection timeout for example, 1 minute, and this is a big value, of course, it means that you allow a node to be in a stop the world garbage collection for even 1 minute. So the next group of issues are issues with Ignite storage, with how you access your data. So the first kind of issue here would be various out-of-memory errors. And there are actually 3 kinds of different out-of-memory conditions that you might see in Ignite. First is Java out-of-memory exception, just the usual one. The other one is a special Ignite out-of-memory exception. And finally, there are some situations when you won't even see any exceptions, but you will just see your OS killing either Ignite's process or maybe even some other process in the same on the same host. So what causes Java out-of-memory error? So as most of you know, this error usually means that you don't have enough Java heap size. In some cases, it would mean that, yeah, your heap is just too small for your application. There aren't any actual issues with how you use it. It just needs increasing, and you can just do that. Another kind of issue are SQL queries, and this is very common in Ignite clusters, that large SQL queries cause some of these out-of-memory errors, because SQL uses a lot of Java heap. Basically, when you do, by default, when you do an SQL query, you will collect all of the data that you have queried on the Java heap. So if your heap is, say, 2 GB and your SQL query returned a lot of the data, like 10 GB, you will get out-of-memory error. How to avoid that? First, you can use lazy queries, and you can check out more in the documentation. But how they work is that instead of loading all of the data onto the heap, they will load the data onto heap page by page, by small portions, greatly reducing the maximum size of the heap that you need. But unfortunately, not all queries can be used as lazy ones. For example, if you have aggregation, if you have keywords such as group by, distinct, order by, you might not be able to use lazy, because you will still need all of the data at once on the heap. Also, you should avoid having a lot of queries that query a lot large portions of data running concurrently, because even if each one of the queries does not consume all of the heap, altogether they might just need too much space. And finally, if nothing helps, and if you see that you have this giant query, say you can't use lazy with that, and it just does not fit into your heap, and you can even increase it, then you might need to split the query and to change how it looks to so that it returns less data. For example, if you have some temporal data, you might first query one period of time and then query the other period of time and process them together, like glue them together on your application side. The next kind of out of memory is Ignite out of memory. And unlike Java out of memory, it is related not to Java heap, but to off heap memory. Off heap memory is where Ignite stores all of your actual data in a deserialized form. In a serialized form, sorry. So the message will look like the one that you see on the slide, and you can see that the message itself actually suggests all the different ways that you can solve it. So first, you can just increase the amount of heap data of heap memory that is available to your caches. You can also use Ignite's native persistence, because if you use native persistence, meaning you use disk as well as RAM, excessive data will be just swapped to the disk, and you will never get this out of memory exception. And also you can use eviction and expiry mechanisms, which allow you to get rid of some of the data. Eviction is a mechanism that removes some data when you reach your off-heap memory capacity. And expiry is a mechanism that removes the data by timestamps, that removes the data that is old and wasn't accessed in a long time. Finally, an issue with operating system killing processes. So operating systems have this mechanism that is called out-of-memory killer. What it does is, when the system itself starts to run out of memory, the operating system itself, the kernel itself, might have to decide between just crashing the whole system and freeing some memory by killing some of the processes that consume it. And of course, usually operating system would choose the second. So if that happens, you will see a message like the one that you see on the slide. And to avoid that, first make sure that the total size of all of your processes, not just Ignite, but also of other processes running in the same system on the same host, their total memory size is within the size of the physical memory on that system. And you can also try disabling memory overcommit feature, but use it carefully, because some applications actually rely on that. And what overcommit does, it allows the processes to claim more memory than the system actually has. But if they actually try to use all of that memory, which the system doesn't have, then you will see these OM killer issues. So the next kind of issue with memory and with storing data is when you see that you have lost some data when restarted a node. So how can you detect that? Well, it's easy. Say you have just restarted a node and you check the web console metrics for cache sizes, and you see that the total size of the caches has actually dropped after the node restart. So why is that? First, you have to remember that, and this is all I need to say, this is all related to in-memory caches only, not persistence ones. So by default, Ignite caches have 0 backup copies. It means that when you take down one node, you will lose the data that was on that node, and you don't have any backup copy in the cluster. It means that by default, if you use default setting for your cache with 0 backups, taking down a node, restarting a node will always lead to some data loss. So you can only use 0 backup mode if you use persistence, or if you store some data that is not critical or that can be restored from some other sources. If you use backups, actually one or more backups, then you can stop multiple nodes simultaneously, but make sure to always wait for rebalance. What does it mean? Say you have one backup and you have restarted one node. And if you have just restarted one node and want to restart the next one, if you do it right away, then you will see some data loss, because the node that you have just restarted, it doesn't have any data yet. And right after the restart, you actually have less backup copies than you have configured. You need to wait for the end of the rebalance process for backup number to be restored, and only after that you can proceed with restarting other nodes. You can monitor rebalance in Web Console on the rolling update screen, and you just wait for rebalance status to say that rebalance is complete. Next kind of data, and this is now about accessing the data, is when you see that SQL returns less data than you know it needs to return. So say you have uploaded some data during the testing, and you know how much data, how much rows a query needs to return, but you and the query has a join, and but you see less data as a result. So why does that happen? So it usually happens because your data is not collocated. And I will not go over this affinity collocation in much detail, because we need to speed up a bit, unfortunately. But what it means is basically that your SQL queries are executed on each of the nodes separately, and then the data just concatenated together on the client node, on the node that made the request. Because of that, if some of your data, for example, an organization and persons who work on that in that organization are not stored on the same node, then you might see that the join between these tables don't return all of the data. The options that you have is first to set up affinity collocation, and to do that you need to specify an affinity key, or you can use replicated tables, which means that table will be stored on each and every node. Or you can use distributed joins, which means that the joins will not be done on each node separately, but on there will be data joined between the nodes. But this is extremely bad for the performance, and you should only use it as a last resort. Next kind of issue is nodes not being able to store your data. How can you detect it? You just take a look at Web Console again, and you see that some nodes have some reasonable data size, and some have zero or almost zero. Like here, some nodes store hundreds of megabytes, and some store just less than a megabyte. And this happens because of the baseline topology issues. What it means is that basically the baseline topology is a set of the nodes that are allowed to store the data, and this is only applicable now for clusters with Ignite native persistence. And if you just started a new node, it will not be a part of the baseline, and it will not store the data. To make sure it stores some data, you need to include it into baseline topology. And again, you can do it with a screen that is made just for that in Web Console. And the next, the final group of issues, and I will have to go over them quickly, is performance issues. There is just a couple of them that I want to talk about today. The first one is low throughput of cache updates. So say you have native persistence enabled, and you have a throughput picture like this, like the one on the slide. So sometimes the throughput is high, and periodically it drops to flat zero. Usually it happens because the updates happen too fast for the disk to process. So Ignite is a memory-centric system, and it writes to memory first, and then it writes to disk. But if you write to the RAM with the RAM speed, and then you will see that, and you always use the full RAM speed, then the disk will not be able to catch up, and after some time, Ignite will have to block all of the updates, all of the new updates for the disk to synchronize and for the disk to catch up with what has been updated in the RAM. To avoid that, the best way is to configure write throttling, which is a mechanism that basically evens the performance, even your write performance, with what your disk can give you. So your maximum throughput will not be as high, it will be somewhat lower, but it will be stable, and you won't see these peaks of throughput and drops to zero. And final issue that I'd like to highlight is low throughput of SQL access. And this is a really giant topic, or of course, tuning SQL. But one issue is very, very common, and this is an issue that is related to indexes. So, common cause for low in the SQL performance is that inline size for the indexes is too low. So, inline size is the amount of bytes that are inline from your indexed columns into the index tree. And if it is too low, then you can't compare values just by using indexes in place, and you have to go all the time to the actual data where the actual data is stored, perhaps even to the disk, instead of just using indexes when searching. And if that's the case, if you use a new version of Ignite, Ignite 2.7, and that's the last one, then you will see a warning just like the one on the slide, which will explain what's happening and explain what you need to do. It will show the table name that performs suboptimally. It will show the name of the index that has too low inline size, and it will give you some suggestions on how to change that index size, either using configuration or by using system properties. So we've covered all of the issues I wanted to talk with you about today. So this is a checklist, and unfortunately we don't really have time to go over it, but this is just a summary of what we've talked today. Be sure you're prepared. Be sure that make sure that you have monitoring set up, you know your tools, and that you know the common problems that happen in the Ignite and GridGain clusters, so you can react. And finally, if you want, there is some list of Ignite community resources and GridGain resources if you're interested in GridGain. And if you have some questions, the best way to ask them, the best places to ask them are Ignite user list and Ignite Stack Overflow, or you can just write to me. My emails are on the slide. So, Nicole, if we still have time for a couple of questions, I'm ready to answer them.
Yes, I would like to take a couple of questions as we have some coming through. If any of you have any questions to ask Stan, please type your question in the Q&A panel now. We have received a couple of questions, and one of them is, I have observed that on Windows system, Ignite client takes long time to connect to a cluster than that on Linux. What could be the possible reasons?
To be honest, I haven't seen specifically issues related to Windows, so it's not perfectly clear whether it is Windows clients connecting to Windows clusters or Windows clients connecting to Linux ones. But one thing, I would assume that Windows would be like development laptop and Linux would be perhaps some other server. So maybe you need to check the connectivity and what are the routes from your PC to the cluster, and how what is the path that client takes to connect. But can say much else. If you experience this a lot, I would suggest you take this question to Apache Ignite user list, attach your logs, attach your configuration. Maybe it we will be able to solve this.
Thank you. And the next question is, even after setting maximum GCP pause mails to 200, I could see sometimes GC post message like post for 500 or more than that.
Sorry, Nicole, could you please repeat? So
Yes,
maximum GC,
even
yeah.
after setting maximum GCP pose mil is to 200, I could see sometimes GC post messages like post for 500 or more than that.
Well, yeah. So that message, that option, and we are talking about. Yeah, let me just quickly find that. So, and we are talking about this one, I guess. This is just a soft goal for G1 garbage collector, and it will try to achieve that. But if you just have, well, too unhealthy heap usage, or just too large heap, for example, too fast allocations, G1 will still not be able to reach that goal. This by specifying this, you just say like what is your own target. A bit, it might sound like a paradox, but a lot of the times I would see specifying a softer, even larger max GC pause millis time helping. So, for example, if you have 200 here, it means that G1 will try very hard to fit into 200, but if it can't, then it will fail, and it will fail miserably. And what you will see is that the larger pauses will actually be like very large. But if you set a larger goal here, like 400 or 500 or even 1000, if you can allow that in your system, then G1 will do a better job of fitting that specific goal and will more likely have more uniform GC post time. So I would suggest that. And again, using this tool, GC Easy IO, helps a lot when analyzing GC logs. I suggest you start with that.
Thank you. We'll take one more question and then we'll close off for today. When we connect 5 nodes in a cluster using static IP finder, the cluster splits into 3 nodes or 2 nodes. All 5 nodes does not join. What could be the possible cause of this?
Oh, well, it's static IP finder, and 5 nodes are all configured in the 5 addresses are all configured, but it still splits. Well, first, there might be a connectivity issue again. So first, just make sure you don't have like firewall issues, connectivity issues. Make sure that ping works. And second, to troubleshoot that, I would suggest that you make sure you start the nodes one by one, and you see when you start which node it doesn't connect to the previous cluster. So say you have started 3 nodes and they are all connected, and then you try to start the 4th one, and that one does not connect to the first 3. If that's the case, then probably there is a connectivity issue from the 4th node to the first 3. I think that's a route to check.
Thank you. And that's all we have time for, I'm afraid. So I would like to thank our speaker today and thank each of you for joining us and your participation. Thank you and have a wonderful day.
Thanks all.